Okay, so now, if the rover operates autonomously...
Yes. Why do I need, what do I get paid?
Yeah.
Well,
I mean, do you just come in every day and say, yeah, it drove?
Actually, preparing the commands for the vehicle is pretty easy. Mm-hmm. The difficult part is being a pessimist. That is, imagining all the possible wrong things that can go on Mars and prevent the vehicle from getting into those situations. So the first thing that we want to do is to make sure that the vehicle doesn't get into trouble. So make sure that the vehicle is capable of detecting unsafe situations. The second best thing that we can do is autonomously have the vehicle determine potentially unsafe situations and avoid them so that you can continue driving. But if the first law of robotics is going to fail in this case, that is, if it cannot find an autonomously a safe path to go, it's going to simply stop and ask us for help.
I thought the first law of robotics was don't attack humans.
At the moment, we don't have any humans on Mars.
Oh, good point.
You're the lead flight systems engineer for MSL.
That's correct.
So you got a pretty important job.
It is pretty fun.
And what's that all about?
It's making sure that the avionics and the flight software play together, and we also have to command the vehicle and making sure that the whole ground system can communicate the avionics and the flight software to ensure that we can get EDL done correctly.
As a flight systems engineer, take us through that process, and what are you trying to look for in the data as it enters the Martian atmosphere?
Before we get into the 7 minutes of terror, so about 40 minutes, we kind of start prepping the vehicle for EDL. And so at that point, we have lots of telemetry telling us how it's doing. You know, we give our last poll, we're good to go, put it on its way, let's stop commanding it. And then about 10 minutes from entry, we do our cruise stage separation. So we get rid of the cruise stage that got us there, you know, get our thermal batteries ready, make sure that the vehicle in its encapsulated form will get us down.
Okay.
But at that point, there's a flight software that's called the EDL timeline that works in concert with the guidance and control to make sure those last minutes are very scheduled, basically, all the way down.
So at what point is it fair to say where you're pretty confident that MSL has landed safely and that it's ready to go?
So it takes about 20 seconds for the descent stage to fly away. So when the descent stage will bring us down, it's touchdown, it'll internally go into its own control mode and fly away about 500 meters. That takes about 20 seconds. So we'll basically be waiting a little bit after touchdown to make sure that everything's happy and healthy.
So you have like any inner office polls to determine where that ascent stage lands on the surface?
I think we're going to end up having something like that.
So I've been helping the EDL team in the past 4 or 5 months doing stress and robustness testing. So we actually throw a ton of anomalies into this test we do that's testing the sequence of events that occur for EDL approach and EDL, and we've thrown some crazy anomalies at this thing and it's been able to land.
Now what are some examples of those anomalies that you've kind of thrown at MSL?
In the tests that we've been doing for testing, like during the EDL approach phase, some examples is we'll trip different fault responses. So either think temperatures are too hot or too cold somewhere, and the flight software has to respond to those things. And we'll even have a computer reset and make sure that the system can recover itself and still land safely.
And has the rover done a pretty good job so far?
Yeah, it's amazing some of the things that we can throw at the system, and it's still able to land.
You've obviously been out here in the Mars yard practicing, but right now, Curiosity is en route. And
yes.
Are you guys going to go into like hibernation days before the landing so that you can be up for all the intense activity once you land successfully and begin operations?
I don't know if I'm going to be able to sleep.
You'll be where when Curiosity finishes those 7 minutes of terror and it starts operation? Where are you going to be?
I'm going to be part of the team that is going to localize the rover. That is, try to find where on Mars the vehicle has landed exactly.
Like Google Maps, when you hit the little button and it locates you?
Yes. Okay. The fact is that we don't have streets. We don't have street names on Mars.
Roads, where you're going, you don't
We don't have a GPS. So the vehicle is not going to tell us immediately where it has landed. It's going to give us some ideas. It's going to give us some clues. There is going to be some telemetry. There's going to be some images. Potentially, like trying to find a needle in a haystack.
Wasn't it true that for Spirit and Opportunity that the airbag system was actually at its limit in terms of the
Pretty
mass?
much, yeah. So there were lots of testing, and the testing that was done showed that. You know, the mechanical guys went through an ice trade and showed, look, there's no way we can do this, right? The forces are just too strong. The airbags will get torn to shreds, right? So in Skycrane, we traded the mechanical complexity of MER for the guidance and control complexity of the Skycrane system, which is a huge mass saver. So now we can land something as large as MSL rover. And so on MSL, making sure this thing works required a lot more people. And so the team is ballooned. And you would imagine that with a larger team, you'd have full coverage, but given the complexity of the system, we're still trying to make sure things are all pieced together, make sure that all the, you know, check boxes are checked and everything's ready to go.
And it makes your job even harder because, you know, with the vehicle this size, I mean, this is just a scarecrow because this is not the total vehicle. But imagine, you know, a rover this size has never even attempted to land on a planetary surface before. This is going to be the first time. So this is going to be a record.
It will be 900 kilograms.
Absolutely. Probably a Guinness Book of World Records. You know,
nice.
you need to call them up. But from your perspective, I mean, your job now just magnifies as the flight systems engineer on MSL compared to, you know, MERS.
Right. It just becomes a lot more, what's the word? Scary.
You had mentioned that the spacecraft is constantly awake since it left the Earth's surface and is heading to Mars. Is it on medication the whole time to stay awake? I mean, how's it able to stay awake 24/7?
Well, it has solar rays, so that helps.
So do you have engineers staying up 24/7 to make sure it's responding to the spacecraft?
Actually, in the few days after launch, we did have 24-hour operations going, you know, making sure like our new baby spacecraft has people watching it. And in the last probably 9 days prior to EDL, we are going to have people watching it more closely 24/7. But for the most part, we watch it like once per day. We've got coverage with our antennas here on the Earth to get telemetry from it for a chunk of the day, usually every work day. The engineers that look at the health and status data and make sure it's okay at that point in time, and then we'll say, see you tomorrow.
People are watching you live right now on our NASA Ed webcast, but you're not here.
No.
You're in the control room, right?
We'll be in the control room around now.
What are you feeling right now?
Probably scared, a little nervous, but knowing that we've done everything we can to make sure this thing is ready to go, and having that peace of mind, and hopefully we'll be down in a couple of minutes and happy.
You know, you're working on such a complex piece of machinery, and something does go wrong. I mean, what can you tell us up-and-coming engineers what to expect when you're working on projects as complex as this?
Well, there's always something to learn, right? Even if it goes right or wrong. So you're going to learn something. And so what you learn if something goes wrong is how to do it right the next time. And so we'll have opportunities in the future to do this again, and if we do fail, right, we will go to Mars again. And hopefully, if in the event that something goes wrong, we will do it better next time.
Is something that the Humvee cannot do.
All right.
Which is turn in place.
Yeah, nice. That brings up another question. How long before this technology can be implemented in my Honda Accord? So I hope that, you know, sooner rather than later, because I just like to relax and drink coffee while I'm driving. So it's obviously safer if it's autonomous.